My name is Richard Muturi. I'm Country Operations Manager for Nairobi Bottling Limited in Nairobi, Kenya. As we are aware, fuel is a major cost component, and in Nairobi, Kenya, it contributes to 11% of our total logistics cost. This year, we started off on a key initiative, what I'm introducing to you as a fuel management system. We introduced this system 2 months ago, and the main objectives was to improve on the costs. We use the system to improve how we manage our fleet asset base. And we're also seeing in the long run how it will play a role in the route to market costings. Critical improvement on this is as follows: to improve the schedule, routine, and maintenance using the fuel consumption to manage the mileage and hence determine the routine maintenance and scheduling of the same. Point 2, fuel costs being so high, we have seen in this system over the last 1 month that different routes, despite being the same distance, can actually cost more to deliver to our customers. And I believe that in the long run, this system will play a very vital part in our route to market costings. Third part is using the fuel in terms of determining how and when we replace our vehicles. They are amongst other criteria, but we believe also how the fuel consumption is being used on a vehicle can determine whether the vehicle is fit to keep or replace in the long run. Finally, we had a very big problem in Nairobi and business around fuel siphoning. This system, and we will see and demonstrate on the video that we will see shortly, how using the GPS tracker, using the routing that the vehicles are using, we are able to identify in real time, coming through your phone, if any fuel drops at any one particular point in time, which is more abnormal than how the engine consumes the same. Overall, in this project, we anticipate and expect to see a saving of about $10,000 per month coming through each month, which is significant comparing to the investment that we're putting in place. We believe we can roll this initiative across the rest of the SABCO business. There's a lot of interest coming through this process right now. We just need to make it more cleaner and make sure that we can get the support across the wider region and as a best practice to share. In the coming video, I hope we will explain in how the system works. It's very important to understand the components that go into the system. They do not interfere with the mechanical processes of the vehicle in any form or manner. There is a real-time tracker that comes along and can also be used as part of the tracking system that we have on our existing fleets. And it gives real-time messaging and posting. If a fuel level drops by more than 5 liters at any given minute, you will get a notification immediately within 3 minutes where the vehicle is and the quantity of fuel that has dropped.
What you're about to see is installation of a fuel level sensor. This is new cutting-edge technology in fuel management, whereby the sensor is incorporated into a GPS/GPRS unit. Here we start by preparing the vehicle. In this case, we drain all fuel from the tank. The reason being to prevent any fires during the time of drilling. After all fuel has been drained from the tank will be removed from the truck for ease of installation. Once the tank has been removed, you examine the tank for internal partitionings because the fuel level sensor should not come in contact with the partitionings inside the tank. Here you have to find a geometrical center of the tank. You use a circular saw to drill a hole. Once the hole has been made, you use a measuring tape to get the depth at the point where the level sensor is going to fit. The level sensor comes in a variety of lengths. So at this point you have to cut the level sensor to a suitable length that will be able to work in the tank. After this, you put a sealant at the end of the tube core. This one prevents moisture buildup inside the sensor. We go now to calibrate the sensor itself. In an inverted position, the sensor has perforations at the base, so the base is sealed up. The reason being the level sensor has to be calibrated using the type of fluid that is going to be applied on. And in this case, we're using diesel fuel. Here we get to calibrate for empty and set the values, and also full, where we also set the values. Here we use silicon sealant to prevent any future fuel leaks from the tank through the sensor. Once the sensor is calibrated, we then now permanently plant it on the tank. The sensor is then screwed on the tank to make a tight fit. Once this is done, the tank is then mounted on the truck before now actual tank calibration can begin. For accurate calibration, here we are using a fueling station that is easy to use the metering. In this case, we'll be using a frequency of 10 liters to get our calibration. Now on our computer, we have a platform that we use for calibration of the level sensor. After adding every 10 liter, the indicator at the middle of the screen will show yellow. At this point, the sensor is trying to get a stabilization code. After turning green, you give it some few seconds before a final value is entered. For accurate calibration, at least not less than 20 values should be entered, all the way until the tank fills up. Now, the number of calibrations will depend with the type of tank you're dealing with, because we understand tanks are of different shapes and sizes. But this level sensor is designed to work in all manner of tanks. On the left column, it's the column for liters, the amount of liters that we're going to put until the tank fills up. On the right-hand side are the sensor codes that are generated after every 10-liter fill. Now, after the calibration is done, the level sensor is wired to a GPS GSM unit, which in this case will be sitting inside the passenger cabin. This is a tracker device. Now, the tracker device has got a connector that powers the system, this unit, and also it has this small connector that the fuel level sensor connects to. Still on the same tracker, there is the GPS antenna, which is this one, and the GSM antenna. Now, the two devices, the way we have programmed, they're supposed to work well. GPS unit, the tracker device, is the one that relays information from the fuel level sensor to the transport manager's computer, so that any variation of level, fluid level inside the tank is relayed by this device through GPRS.
As you can see from this graph on your screens, the green line is fuel consumption in 2013, and the red line is fuel consumption in 2014. We kicked off the year on a very average kind of performance, and in February we had a major fuel siphon happen in February, dropping the fuel to even below where we were last year. We corrected that through some disciplinary actions, and in March we saw an improvement in the fuel consumption. In April we saw the best, that was mainly volume driven. During the months of May and June, we started installing the fuel management system. In July, we commissioned the system, and in August, we've seen the highest fuel consumption improvement rate that we have seen so far. I believe that the system is working, and we hope to see that this trend continues for the balance of the year and as we move into 2015.